everyone. Today we're going to look at exponential functions. The most basic type of exponential is y equals b to the x. Notice the variable is in the exponent, hence exponential. B is called the base, and in order for this equation to make sense, in the real numbers anyway, we're going to have b is greater than 1. B could be, in theory, between 0 and 1, but what we do is we want to rewrite it. So if I had b being 2/3, which is less than 1, I'm going to change it using rules of exponents. I'm going to flip the fraction into 3/2 and make the exponent negative. The base can never be negative because then we're looking at imaginary numbers for some of them. So b always has to be positive, and if it's less than 1, then we rewrite it using rules of exponents and we change the sign of the exponent. Okay, so we're always going to think of b being bigger than 1. So let's start with y equals 2 to the x. What does the graph look like? If you don't know right away what a graph of some function looks like, you can always make a table. So we're going to do the integers from -3 to 3. So remember, x is the independent variable. It can be any number. It can be integers, it can be fractions, it can be decimals, it can be positive, it can be negative, it can be 0. The x you can choose anything of. The y depends on the x. So if I let x be -3, then I have 2 to the -3. And remember what negative exponents mean. 2 to a -3 means I'm looking at 1/2 to the +3. And 2 cubed is 8, so we get 1/8. If I plug in -2, 2 to the -2, 1/2 squared, which is 1/4. 2 to the -1 is just 1/2, which is what I have here, 1/2. Anything to the 0 is 1. So it doesn't matter that my base is 2. If I raise it to the 0, it's 1. That's going to be really, really important when we talk about our graphs. Anything to the 0 is 1. And then I'll plug in 1. 2 to the 1 is 2. 2 squared is 4. And 2 cubed is 8. The next thing I'm going to do is I'm going to plot all these points. My circles are kind of big, so those look like they're resting just above 0, right? The negative values are fractions, so they're going to be fairly small. Next thing I want to do is, if that's enough points, I want to draw out the whole graph. If I feel like it's not enough points, I can always plug in more values into my table, okay? But I'm fairly confident that my picture is going to look like this. So what we're going to do is we're going to notice some things about this graph. If I have a positive base, which again I'm always going to have because otherwise we're going to get into situations without real numbers, then no matter what power I raise it to, whether it is positive, negative, an integer, a fraction, a decimal, it does not matter. Whatever power I raise it to, my answer is still going to be positive. I cannot raise a positive number to a power and get a negative. So all of these numbers are positive, which means my graph is only in quadrants 1 and 2. So my y has to be positive. Okay? Another thing to notice is that as x gets really, really negative, -10, -20, -1,000, then again I have fractions, and they are getting, the denominator is getting bigger, but the numerator is still 1. So it's 1/2 to the 10th, 1/2 to the 500th, 1/2 to the million. Those numbers are getting really, really, really close to 0, and that is called an asymptote. So when I get numbers that are getting closer and closer to a particular y value, then I have an asymptote at the line y equals 0. So it's not the number 0, it's the line y equals 0. I'm getting closer and closer to the x-axis. Okay. So those are things to keep in mind. My y values don't change signs. If it is always positive, unless, of course, I multiply this whole thing by a negative, but I'll get into that in a minute. So just b to the x, always positive, always goes through 0, 1, because anything to the 0 is 1, and it has an asymptote at y equals 0. So what we're going to do is we're going to play around with this graph a little bit. We're going to multiply it by numbers. We're going to possibly change the exponent. We're even going to add numbers to it. But I want to start with this basic picture here. Everything is going to be based off of this. I might move it. I might move it up and down. I might flip it. I might stretch it. I might rotate it. But it always starts with this same picture. So I want you guys to make sure you have this picture, this image in your mind. And then we're going to play around with it. So you're going to have this following chart. It's very similar to the one in your book. It might not be exact. But what it's got here is, it's got two columns, y equals a to the bx, y equals a to the b, a times b to the negative x. So you want to look at, is my exponent positive or negative? Okay, so that's the difference between the two columns. I have a positive exponent on the left, I have a negative exponent on the right. For the rows, I have a is positive and a is negative. So a is the coefficient. It's something that I'm multiplying my exponent by. There are things that these graphs have in common. There are things that they have different. So let's look first at what they have in common. What they have in common is that if x is 0, then I have a times b to the 0. B to the 0 is 1, so I get a. So if I take my exponential before it went through 0, 1, but now I'm multiplying it by a, and they all go through the point 0, a. So this guy here, for all of them, is a. Notice in the top row, my a is positive. In the bottom row, my a is negative. It's below the x-axis. Okay. Another thing to note is that they all have this asymptote that we talked about earlier. It is always going to 0. On the left side, when the exponent is positive, then it goes off to 0 as the numbers get more and more negative. In the right column, where x, or the exponent, is negative, the exponent's negative, the asymptote is when x gets bigger and bigger in the positive direction. Okay? So again, they all go through 0, a, and they all have an asymptote at y equals 0. Now notice, I'm going to clear out all these pictures so that I have a clear picture again. Okay, so the picture that we were dealing with earlier, y equals 2 to the x, is this guy here. My a was positive because it was 1, and my x was positive because it was just 2 to the x. So this is the picture that we had before. If I start with this picture and then make a negative coefficient, so I go from 2 to the x to negative 2 to the x, or negative 4 times 2 to the x, then what I'm doing from here to here is I'm flipping my picture across the x-axis. So these guys get flipped, these guys get flipped, and these guys get flipped. Everything is just flipped upside down. If I go back to my original and I change the exponent, I make the exponent negative. If I looked at y equals 2 to the negative x, y equals 4 to the negative x, then what I'm doing is I'm flipping my picture across the y-axis, and things get flipped this way. Okay, so if I make my coefficient negative, I'm flipping across the x-axis, or upside down. If I make my exponent negative, then I'm flipping across the y-axis, or I'm flipping sideways. If I make them both negative, which is down here, I've done both. I flipped it across the x-axis, and I flipped it across the y-axis. Okay? So what you're going to be doing in these problems is you're going to sketch the picture based on the equation and this type of graph. So you're going to be given these 4 pictures. You're going to have that for the tests. And so we're going to do some examples of that, but you're just going to sketch it. So what I'm looking for is the y-intercept correct? So if x is 0, do you have it going through the correct point? Is it correct on the x-axis and y-axis? Is it positive or is it negative? And then is the shape correct? So which of these 4 guys is it? So you're going to have to be able to figure out which of these 4 things it is. And then again, make sure the numbers are correct. So the intercept, the shape, the direction, and the asymptote. You want to make sure the asymptote is correct. So we're going to try that with the following examples. A, y equals 2 times 3 to the x. So notice the coefficient is positive and the exponent is positive. So since they're both positive, we're going to be looking at that same first picture that we had done with y equals 2 to the x. Okay, so I know the general shape is going to be this picture here. And then I need to put it on the graph so that they make sense. So what I'm going to do is I'm going to plot the y-intercept. And remember, the y-intercept is when x is 0, and if it's a times b to the x, then a times b to the 0 is just a. So in our case, if I plug in x is 0, I get 2. So I got to make sure my picture is going through 0, 2. I also know, based on this general shape that I drew up above, that it's going to have its asymptote as x gets more and more negative. And then just to really drive home, I'm going to have at least one more point in the positive x values. So I'm going to plug in, say, 1. If x is 1, what's y? So 2 times 3 to the 1. 3 to the 1 is 3. 2 times 3 is 6. So I'm going to plot, it's kind of not very nice, close enough. I'm going to plot 1 comma 6. And then I'm going to continue with my picture, the shape of it. Oh, that was terrible. It's going to go up like that. So you want to make sure your curve is actually a curve, but it's not a straight line. And just try your best. But again, I'm looking for the shape, the asymptote, and the y-intercept. And make sure that it makes sense. Okay, I don't want to have to draw my graph, excuse me, something like this, because those values here don't make any sense. So that's why I'm suggesting to do at least one more to see how steep your curve is. Okay, so don't do what's in blue because that's terribly wrong. So I'm going to erase that. Okay, but now for blue, I'm going to do B. So 4 times 2 to the negative x. So again, our a, our coefficient, 4, is positive, but now our exponent is negative. So if you're looking at your 2x2 setup of equations, it's going to be the top right. The exponent's negative, but the coefficient is positive. That means that our curve is going to have the general shape of this guy. Positive, but flipped across the y-axis because the exponent is negative. So again, I'm going to plot a couple points first. When x is 0, I have 4 times 2 to the 0, which is 4 times 1, which is 4. I'm going to go through here. And then I'm going to choose a negative x value so that I have something that's not just going to 0 on the positive side. So I'm going to plug in, say, negative 2. So 4 times 2 to the negative 2, and now that I think about it, that's going to be too big. So I'm going to change that, and I'm going to plug in negative 1. So 4 times 2 to the negative negative 1 is 4 times 2 to the 1, which is 4 times 2, which is 8. So at negative 1, I'm going to be at 8, which is right there. I could also choose a value that's positive. If I chose, say, positive 2, 4 times 2 to the negative 2 is 4 times 1 over 2 squared, which is 4 times 1 over 4, which is 1. So if I plugged in 2, I'm going to get out 1. And again, those points match up with my picture, so I'm going to connect them and draw it out. I've got the asymptote as x goes to the positive infinity. I've got the y-intercept at 0, 4. It's got the correct shape. Okay, so again, those are things you want to pay attention to when it just says sketch the following exponentials. What if, instead of just taking our exponential and multiplying it by a number, we also add a constant? So we can have a times b to the x plus c. C is going to move the graph up if c is positive, or down if c is negative, the absolute value of c units. So if it's plus 2, we're going to move the graph up 2. If it's minus 4, we're going to move the graph down 4. Note that the y-intercept has been changed. And remember, everything's moving up or down. That includes the y-intercept. So if x is 0, I've got a times b to the 0 plus c. Again, b to the 0 is 1, so I just have a plus c. So my y-intercept is 0, comma a plus c. My horizontal asymptote was at y equals 0, but that's also being shifted up or down, and now it's at c. So now we've got the line y equals c as our asymptote. So if we have plus a constant, we need to take that in consideration. We're still going to use that 2 by 2 set of 4 graphs to figure out the shape, but then we're going to have to move it up or down. So we're going to see what that looks like in the next 2 examples. So y equals negative 2 times 3 to the x plus 4. So here I'm going to ignore the plus 4 for now to figure out which of those 4 general pictures my graph is going to look like. So my a, my coefficient is negative, but my exponent is positive. So that is going to be the bottom left, if I'm remembering this correctly, of those 4 pictures, which hopefully you can go back and look at. Okay, so negative coefficient, but positive exponent has this general shape. The asymptote is still as x goes to negative infinity. Again, we have to remember that things are being shifted up 4 units because of this plus 4. So the first thing I'm going to do is I'm going to plot my y-intercept, which again is a plus c. So negative 2 plus 4 is 2. So I've got my y-intercept. My asymptote was at 0, but again it's being moved 4 units up. So I am going to use in a green line my new asymptote. So again, it was at 0, now it's at 4. So I'm going to do kind of a dotted line type thing here in green. Okay, that's going to represent my new asymptote. Okay. So now I need to consider that green line to be here in my picture and make sure it goes through my asymptote, my y-intercept. Again, just to make sure that my graph's going to look good, I'm going to plug in another number. So I'm going to plug in, say, 1. If x is 1, then I have negative 2 times 3 to the 1. That's just negative 6. Plus 4 is negative 2. So I have 1, negative 2. So that's going to be there in my picture. And again, that's following that generic picture that I have up top, so that makes sense. And then I'm going to connect them. My asymptote, oops, I can't really see as I'm drawing here, maybe I'll go backwards. Close enough. Right, so again, the asymptote is now at 4 instead of 0, and it's got that same shape, it's going through my y-intercept. Okay. Let's try B. Coefficient 2, positive, exponent, negative. So that means I'm looking at the top right of that 2 by 2 set. And the picture, general picture, is going to look like that. I'm going to move it because it's right in my numbers. So it's going to look something like that. And again, that's the original picture flipped across the the y-axis. Okay, so again, the first thing I'm going to do is pick my y-intercept. A plus c, 2 minus 3, negative 1. And I'll make that a little better. Okay, and then just like before, I'm going to draw in my new asymptote, which is c, which is -3. That's really thick. I didn't mean to make that one. So my new y-intercept, my new asymptote, I keep switching them, I'm sorry. My asymptote is at y equals -3. And then I'm going to go again and plug in another point or two to make sure that my picture really looks nice. So I'm going to plug in, say, -1. If I plug in -1, then I have 2 times 4 to the 1, which is 2 times 4, which is 8. 8 minus 3 is 5. So I have -1, 5, which is right around there. And again, I could also plug in a positive number. Let's say I wanted to plug in +1. I would have 2 times 4 to the -1, which is 2 times 1 over 4, which is 1/2, and then 1/2 minus 3 is -2.5. So that would be somewhere, around there. Okay. So again, it should be getting closer and closer to -3 as x gets bigger and bigger. And then I want to draw out my shape and make sure it looks like my picture. So this guy is fairly steep. And again, I kind of missed one of my points, but that's not too bad. Okay, so it's got that same shape as I drew up here from the 2x2 graph, but it's been moved down 3 units. Okay. So for the next few examples, it's not going to be graphing, it's going to be using the equations in different types of examples. So one example that's commonly used with exponentials is radioactive decay. So a radioactive substance loses mass as time passes. The mass, y, is given by y equals ae to the -kt for some positive constants a and k, where t is in years. So remember, e here is a number, it's not a variable. It's roughly 2.718, but it is irrational, it keeps going on forever. You should have this in your calculator. How you have it depends on what calculator you have. So sometimes you just have e, and then you do it like you would with pi or like 7 or 2. You know, I'd raise it to a power, I can divide it by 3, I can do whatever I want. Sometimes you'll have something that looks like this, and when you hit it, you'll have e and then automatically the caret to the exponent. And if you have that and you just want e, remember that you want to do it as e to the 1, and that's going to give you e. Some other calculators will have e to the x, and then when you hit it, it's just an e and you don't see a caret. And it looks like, oh, there we go, that's e. But really, what they're looking for is the exponent to go right here. So I would do e1, and that would be e to the 1, which again is e. So please take some time right now and figure out how your calculator deals with e. So again, it's either just e, like my calculator, I have a graphing calculator, it's just e. Some have e to the x, where it then pops up as e to the caret, and then you plug in the exponent, when again e to the 1 is e. Or it has e to the x, but the caret doesn't appear, but it's still secretly there, and you have to do the e with the button next to it. So sometimes it looks a little funny because they'll have this, and then you need to do something like that if you want e cubed. So again, it's really, really important that you play around with that now so that come the test, you know how to use it. We'll see this e come up again. Okay, so I'm going to erase all of this and get back to the actual problem. Okay, so the first question says, what is the original mass of the substance? So the original mass will be the mass at t equals 0. The original, the starting point, t is 0. So y equals a e to the -k times 0. Anything times 0 is 0. So a e to the 0, anything to the 0 is 1. So the original mass is A. If the initial mass was 500 grams and K equals 0.5, find the amount of mass after 3 years. So we're going to want to plug our values in. The original mass, again, is A. I know K, and T is the number of years. So I plug that in. Don't forget about order of operations. Make sure that if you're going to plug this in all at once, you have parentheses around your exponent because that multiplication is happening before the exponent, which is against order of operations. So I want you to plug it into your calculator and make sure you're coming up with the same answer, which is 111.57 grams. Now remember, this is radioactive decay. It's losing mass. Your answer better be less than the original mass, which was 500. Okay, and that's because of this negative sign. Remember, if we go to graph something and we have a positive coefficient and a negative exponent, our function is going to look like this. So as time goes on, our number is getting smaller and smaller, so our numbers better be decreasing. Let's try another one. A population, which is another good example of exponentials, P of x of bacteria increases according to the following formula. P of x equals 3,000 times 1.25 to the 0.15x, where x is in minutes since noon. Find the population at 1 p.m. So you have to be careful here. You got to remember what x is in. So x is minutes since noon. If it's 1 p.m., how many minutes has it been since noon? Well, I know it's been 1 hour, but I want minutes, so that's 60. So I want P of 60, so I'm going to plug in that x is 60. Again, pay special attention to order of operations. I need to do the exponent first, so that multiplication, then raise my 1.25 to that exponent, then multiply by 3,000. Again, I want you to do it in your calculator. Make sure you're getting the same answer. It should be 22,352. So you're probably going to get decimals, but you can't have half of a bacteria. You either have 1 bacteria or you have 2. You can't have 1.3. So if it's something where you can't have a decimal, namely people or living things, make sure you round correctly. Okay? Find the population at 2:30 p.m. So again, I need to know how many minutes since noon that is. So it's 2 hours and 30 minutes. Each hour is 60 minutes. So if I have 2 times 60 plus 30, I'm going to have 150. So I got to make sure that I'm plugging in the right number, which is 150. Again, order of operations, pay special attention. And I'm getting 454,566. Again, rounded to the nearest integer. Again, I can ask myself, do these answers make sense? I go back to my original problem. I look at the fact that my coefficient is positive and my exponent is positive. So I know the general shape is going to be like this. And I know that as my time gets higher, my population is also increasing. So my population at noon, just like before, is my coefficient. It got larger at 1, and it got much larger at 2:30. So it makes sense that my population is increasing. So you always want to make sure, does my answer make sense? And you can think of that in regards to the shape of the graph. Is it increasing? Is it decreasing? Is it going to 0? Is it negatives? Things like that. Okay, so make sure you read through the book and try out the homework, and let me know if you have any questions. Thanks.